We present ShapOrator, through which we enable design iteration for young designers through shape verbalization. Design iteration helps the designers improve their understanding of their problem and gradually improve their solution. Interactions such as sketching have commonly been used to aid in the iterative design process. However, for younger audiences, verbalization might be a better suited interaction as it helps improve their learning abilities and cognitive skills. Therefore, in our work, we study the design process as a cyclic sequence of reflection, intent expression, and design transformation, where we enable users to make 3D shape modifications to a shape template by verbally interacting with our simple and constrained ShapOrator system. Using spaceships as a design context and swept volumes as a geometric representation, we create a multi-component spaceship template that can be modified by changing the cross-sectional shapes of the components, changing their dimensions, or by adding and removing new components in a constrained manner. For our language understanding module, we trained custom models on Microsoft Azure's cloud-based services to extract important information from verbal inputs. Tying all of these modules together is our user interface. Here is a short snippet of our system in action.
Can you make the fuselage triangular? I want the engines to be 50% wider. Can you please add 2 more wings? Let's make the wings 30% shorter.
Using our system as an experimental setup, we conducted a user study on 10 middle and high school students. The study was an open-ended design task, during the duration of which study administrators asked participants for their reasoning behind their design changes. This helped us initiate a reflective conversation with the participants. The quantitative findings from our study showed that participants made an average of 68 changes, with dimensional changes being the most preferred type and the fuselage being the most preferred part. Now, looking at the relationship between verbally expressed intents and their corresponding reflections, we observed that participants reflected on the functionality and behavior of their spaceship and used metaphors, similes, and analogies to describe their design changes. Our study therefore showed that our speech-based workflow enabled the iterative nature of the design process, and we noted that the true advantage and uniqueness of verbalization comes from allowing users to express their designs through functions, behaviors, and attributes, as well as metaphors, analogies, and similes. If you want to know more about our work, please read our full paper that is linked in the description below. Thank you for your attention.